Hi, I'm Nathan, and today I'm going to be taking you through a STAR-CCM tutorial on how to run Couette flow in STAR-CCM. As we can see here, we're starting with a mesh already. If you don't know how to generate a mesh, then follow my previous videos. It was specifically the video where I taught you how to make a directed mesh. So in this video I'm going to be using a directed mesh. Right. So here I'm selecting the physics, the different models that we would like to use. And in this video we're going to be running a simulation at a Reynolds number of 100, hence why I'm selecting 0.05 as the viscosity. So here we want to select the right boundary conditions. For the top and the bottom we're going to be using a symmetry plane, and then for the inside, which is going to be rotating clockwise, we need a inlet velocity. Velocity inlet. So to create this velocity, to get the right velocity field, we're going to use field function. I'm going to define a new field function. So this is a vector field function, meaning we'll have a velocity vector for each point on that inner. So I'm doing it based on the position. You can use sine and cos, but here we're going to do it based on the position. In STAR-CCM there's 0 indexing, so this 1 here is the y and 0 is x. So this is our field function here. Now we just want to select the velocity equal to this field function we've defined. We want to define it by components, and then under velocity we can just select this field function. This is the one we've just generated. So now we're ready for a simulation. The only thing I'd like to do before is create a scene so that we can see these velocity vectors. And we need to select where we can see this, so I'm just going to visualize it in regions on the boundaries. So now we're ready to go. Initialize solution, and then we can start running. And you see straight away the residuals are converging, and you can see the velocity vectors are converging, with the inside rotating and then everything else following. You can see the velocity vectors propagating out here. The other thing we might be interested to see is the pressure. So the pressure is a scalar, so under scalar scenes we're going to select the scalar field pressure, absolute pressure. And the same, we have to select the parts we would like to see this on. And the vector field is converging nicely. So thank you for watching this video. I hope it's been helpful.